We're talking about the binomial theorem today. We all know what a binomial is. It's basically when you have two terms, two unlike terms, right? So a binomial is an expression involving the sum of two unlike terms. And we're talking about the sum, right? So for example, A plus B. And if we have, let's say, A minus B, then that's still a sum, right? Because that's just A plus negative B, right? So we have the sum of two unlike terms. That is a binomial. Often, a binomial is raised to a power, okay? A plus B to the 0, A plus B squared, right? How many times do we run into something like X plus 3 quantity squared? And you know that you have to, be able to do it right off the spot. But what if it's not to the power of 2 or 3? What if it has to be to the power of 6 or 7 or 9 or 11 or 13? Then what we have is what we call a binomial expansion, right? Because we have to expand it. Now, let's talk about them for the first few integers as exponents. So if you have A plus B to the 0, anything to the 0 is 1. So basically what you have is 1, A to the 0, B to the 0, right? Now, if I have A plus B to the 1, and let me just write it like this, A plus B to the 1, that's just A plus B, right? And if you write it more formally, then what is it? It's 1, A to the 1, B to the 0, plus 1, A to the 0, B to the 1, right? Doesn't that give you A plus B? Because here you have A plus B. Now, this one you should know off the top of your head as well. A plus B squared, you know that you square the first one, you square the last one, and in the middle you have 2AB, right? Well, if you write it in this form, you have 1A squared B to the 0, which is just A squared, plus 2AB plus B squared. And if you continue this pattern, you basically have something that looks like this. Now, if you look at this, are there any patterns? Let's focus on the coefficients first, okay? Or actually, let's focus on the number of terms. Here, when n is equal to 0, how many terms do you have? 1. When n is equal to 1, you have 2 terms. When n is equal to 3, you have 4 terms. So at each step, how many terms do you have? N plus 1. Okay? Now, let's look at the first term always and the last term, right? Here the first term is A, 1A to the 1, 1A to the 2, A to the 3, A to the 4, A to the 5. Right? The first term is always this first term raised to the power. And the last term is always the second term raised to the power. So the first and last terms are always A to the n and B to the n. Okay? Now, as you take each term, right? I'm going to basically close your eyes and pick a random term. This one. Add the exponents. What do you get? This one here, I circled this one. It doesn't show up over there. Well, basically this one, if you add the terms, if you add the exponents, what do you get? 4. And 4 is the exponent that you raise this to. It equals n. Okay? What if you take, I don't know, this one? What is the sum of the exponents? 3. And that's the same as its exponent. Okay? So that's that. The sum of exponents is always n. Okay, the powers. Now, let's look at the powers of A. I'm going to take this row here, and I'm going to look at the powers of A. Well, I have A to the 4, 3, 2, 1, 0, and then look at B. B to the 0, 1, 2, 3, 4. So the powers of A go down, and the powers of B go up. And finally, let's now look at the coefficients. Look at the coefficients here. It's 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Do you see how in each row they're symmetric? Okay, that's another quality. All right, now where does all this come from? Well, I'll tell you. This is all Pascal's triangle. All right, Pascal's triangle gives you the coefficients. How do you get Pascal's triangle? Well, it's this. You have 1 and then a 1, 1 for the first two rows. Okay, now this is called, sorry,